Hello and welcome. This is 9.6b, 30, 60, 90 degree special right triangles. This lesson comes after the lesson on 45, 45, 90 degree triangles and works from the understanding that you already have some knowledge of that. It also works from the understanding that you know the Pythagorean theorem. So with that said, we're going to go ahead and get started. In case you needed it, I copy and pasted what I wrote on the last lesson for Pythagorean theorem right here. All right. Given the following triangle, find the missing side. So, things to notice in this triangle. We are given a 30-degree angle and a 90-degree angle, and I can find this third angle the same way that we've done in the past. So I have 30 degrees and I have 90 degrees for that right angle, which gives me a sum of 120 degrees. And we know that the interior angles of a triangle have a sum of 180 degrees. So when I subtract 120 from 180, I get 60 degrees. What I'm going to discover about this triangle, this 30, 60, 90 degree triangle, is going to be similar to all 30, 60, 90 degree triangles. So all of the sides will be in the same proportion. Find the missing side. So I can, things I know again, I can use Pythagorean theorem. This little TH with an M and with the little M is underlined, that is shorthand for theorem. I don't think I've pointed that out before. So I'm going to set up Pythagorean theorem, a squared plus b squared equals c squared. C must be the hypotenuse, and A and B are interchangeable. It doesn't matter which order I put these in. So if A is my variable, or if you want to use X or some other kind of letter, I'm going to plug in 8 for one of the legs and 16 for the other leg. Eight squared is 64. 16 squared is 256. When I subtract 64 from both sides, I get a difference of 192. Oh, factor tree again. Well, 192 is even, so I know 2 goes in there. 2 goes in this 96, 48 times. Let's go for 4 and 12 here. 4 breaks down to 2 times 2. 12 breaks down to 2 times 6. Lots of 2's again. Let's see, 1, 2, 3, 4, 5, 6 2's. And a 3. So I get a pair of 2's. I'm going to bring 1 out, right? Because 2 times 2 is 4. Square root of 4 is 2. 2 times 2, I bring another one out. And 2 times 2, I bring another one out. I have a 3 left inside. 2 times 2 times 2 is 8, not 6, like I mistakenly said in the last video. And it's square root of 3. Now applying this, now when I take the square root of both sides, I get a positive and I get a negative. But when I apply this to this triangle, this real life situation here, I can only have the positive value. I'm not going to have can't have a negative length. So let's fill in our table and look at what we kind of have here. So my short leg, my shortest side there is the side across from the 30-degree angle, right? That's 8. And my long leg is 8 square root of 3. And my hypotenuse is 16. These lengths are all different in this triangle, which just makes it a little bit more work. Well, usually about twice as much work. So my short leg, let's call that x. How could I rewrite the long leg in terms of x? Just replace 8 with x, right? So I would have x square root of 3. Okay, then in the hypotenuse, how could I rewrite 16? Well, would you agree that 16 is the same as 8 times 2, right? So let's write this as 2x. So if I write it with the x, I get x squared root of 3, and 2x. Now, the radical 3 goes in the middle here. It's across from the longest leg. If I take square root of 3 in my calculator, and I plug that in, the square root of 3 is about 1.73, right? Which is clearly between 1 and 2, right? Greater than 1, less than 2. That goes across from the middle length side. All right, let's get after some examples here and see how it goes. So for A, I think I'm going to use the table the first time here, and then I'll use the ratio the first time on the other problems. So let's look at what the table has to offer for this problem. So my expression, the short leg is x, the long leg is x squared root of 3, and the hypotenuse is 2x. What do I know? What length do I have? I have the length across from the 30-degree angle. This is the short side, so that's the short leg. So in this case, this is not too bad to plug in. So what is the long leg? 4 square root 3. And what is the hypotenuse? This is 2 times 4, which gives me 8. Okay, so I could determine that, let's see, this is called y, right? Y is 4 square root 3, and x is 8. Great. Now let's look at this with ratios. I like to kind of draw this little mapping. This is 1 square root of 3, and then 2. And I am always reminding myself that even though 3 is a bigger number than 2, the square root of 3 is 1.7 something. So it's between 1 and 2. So when I set up my ratios, I find the 30-degree angle. Right, here's my cursor. I find the 30-degree angle. Across from 30 degrees, I'm going to put a 1 in a circle. Find my 60-degree angle. Across from my 60-degree angle, I know this one must be 60 since it's not labeled. Maybe a good idea to label it though. Let's label that. How do I know it's 60? Well, I found it above, and so I'm just using that information. If I have a 90-degree angle and a 30-degree angle, the other one has to be 60. So across from the 60, that's going to be square root of 3. And across from 90 is 2. So I can set up proportions. The side I know is 4. What ratio number goes with 4? 1. Let's say I'm going to look for y. So I'm going to put the square root of 3 on top because that's my ratio number in green, and then y on the bottom. And I crisscross multiply. 1 times y gives me y. 4 times square root of 3 gives me 4 square root of 3. I could set up the same thing to find the other missing side, right? I already have I have 1 over 4, and then I could set up 2 over x. I could also not set this up and just use some of my number sense and my brain power to figure out what x is going to be. Check it out, guys. If this short side is 4, and we know the hypotenuse is twice as long, I could tell you that that's 8, right? But let's say you maybe can't come up with that in your mind in the moment of the test, and so you set it up and you crisscross multiply, right? And you'll get it right here anyways. Okay. All right, so let's do another example. All right, so paying close attention here in this next problem, I do have the 60-degree angle marked, right? So let's go ahead and identify that this other one is going to be 30. And this time I'm going to jump right into my ratios because it's kind of how I roll. So across from 30, the short leg is going to be 1. The longer leg is going to be square root of 3. And the hypotenuse is 2. You might be able to work backwards from this and get it really easily. That's fine. You don't have to do all this work if it's if it's unnecessary. But let's say I need to do the work because I can't just look at it and see the answer. Always take one of your known sides. I cannot set up a proportion where I have 2 unknowns. So if you set this up and you have A and B in here, stop. Get rid of one of those and use the known side, like 2 over 4. Now you could solve for A first or you could solve for B first. I'm going to go for B. All right, so check out that setup. Crisscross multiply. I have 2 times B is equal to, the whole number comes first, then the radical. To get B by itself, I have to divide by 2. And when I do that, I get 2 square root 3. 4 divided by 2 is 2. Now, if you need to set up a ratio to find A, go for it. But check this out, guys. The relationship between the short side and the hypotenuse is just twice as big. So if my hypotenuse of 4 is twice as big as the short side, what's the short side? Hopefully you can recognize that it's 2. Maybe looking at the table will help you recognize that. So what did they give me this time? This time I know 4. What is that? That's the hypotenuse. So if I were to use the table, I would work backwards and go to the short leg first, right? If I divide that by 2, I get 2 over here. So I took 4, and I divided by 2 to get 2, which is x. And then what's my long leg? Well, if I know x is 2, then this is just 2 square root of 3. All right, so 2 different ways to do the same problem. You can use what I'm doing in green and blue for your ratios. I'm sorry, what I'm doing up here with the green ratios, or you can do what I'm doing down here in the table. Personal choice. All right, so working through some more of these. They'll just all be a little different. Some of them have radicals and some of them are given, if you're given the short leg every time, they're all the same, but that's different than if you're given the long leg or if you're given the hypotenuse. So let's see, problem C. I know what this missing angle is. It's automatically going to be 30 degrees because the other two are 60 and 90. Let's use the table here first. I'm given the short leg, which is 2 square root of 3. How do I get from the short leg to the long leg? Well, now I already have a radical 3. So to get from the short leg to a long leg, I'm going to multiply by square root of 3. Ooh, so I have 2 square root of 3, and then I'm going to times square root of 3 again. Yes. Excuse me, 2 times the square root of 9. Square root of 9 is 3. So the long leg is just 6. All right, I can dig that. And to get from the short leg to the hypotenuse, I multiply by 2. So when I double 2 square root of 3 times 2, when I multiply these, if you remember, the whole numbers multiply with the whole number, so I get 4 square root of 3. The radical stays the same. Boom, done. This problem's going to be in the way a little bit here. Let's move it over a bit. All right, cool. So if I go back and I use the ratios, across from 30, I'm going to write a 1. Across from 60, I'm going to use a radical 3. Across from 90, I'm going to use a 2. And I set up a proportion. Now you have choices, right? I know I have to use 1 and 2 radical 3 because I have a known side. My other option is to find whichever other one I want. I'm going to go for probably the radical 3 over D. And you can go for whichever pair you want. If you want to go for 2 and C, you can do that too. So I crisscross multiply, and I get D is equal to 2 square root of 3 times square root of 3. Again, square root of 3 times square root of 3 is square root of 9. Square root of 9 is 3, and I get 6. You could set up another proportion for the other leg. I know that C is just twice as big as 2 radical 3, so I could just multiply by 2 in my head. If you're not comfortable with that, we set up the proportion. So I'm still going to use 1 and 2 square root of 3. And this time I'm looking for C. 1 times C is C, and here I get 2 times 2 square root of 3, which gives me 4 square root of 3. All right. D is a little bit different because I have an odd number, so I'm going to end up with a little fraction on this one. And then E, I'm going to challenge you to give it a try on your own, and then I'm just going to give you the solution. So let's work D out together. Let's see, where is that? Let's see, I've got 30 and I've got 90, so this one's got to be 60. Across from 30, put a 1. Across from 60, write a square root of 3. Across from 90, write a 2. These are the numbers that always go with the 30, 60, 90 degree triangle. Now, when you have an assessment, know that these two sections are going to mix, right? So the last section was 45, 45, 90. This is 30, 60, 90. So before you start writing things on your triangle or in your table, you've got to assess what kind of triangle you have, right? They operate differently. All right, let's see. I have 2 and 13 is my known. And I want to find, I don't know, let's go for n. First cross multiply. Divide by 2 to solve for n. And I'm going to leave this as 13 over 2. It's equivalent to write it as 6.5 or 6.5. But I'm going to leave it as 13 over 2. Now I know that when I go, if I have my short leg, then my longer leg is just radical 3 longer. So I could just multiply by square root of 3. It'd be 13 radical 3 divided by 2. I'll set up the proportion just so you have it. So square root of 3 over m is what I'm looking for. And I'm going to use 1 and 13 over 2 so I can show you what a fraction kind of looks like. 1 times m gives me m. And then when I multiply these, you have 2 different ways you could write this. It could look like this, but more commonly, it's going to look like this. And they're the same thing. So it's okay to write the 13 halves in front, or 13 radical 3 divided by 2 is a more common way you'll see it written. All right, what piece of information was provided in my original problem was the hypotenuse, which is 13. So now always go back to the short leg first if you can. Right? So going back here, I need to do 13 divided by 2. And then I'm just going to leave it like that. And then my long leg is just 13 divided by 2 times square root of 3. Boom. Got it. All right. So E, I'm going to ask that you pause this video, give that problem a shot. Like it's a little different from the ones above, but the method is the same. So go ahead and try it. All right, so I've got my setup here. Hopefully you already did it. If I look at this table, I've got my long leg, which is 9 radical 3. Remember, that's the same as x radical 3. So what's the short leg x? Hopefully that's easy to tell that it's 9. And then my hypotenuse is just double that, so it's 18. So those are my answers. If you set it up using the ratios, we would crisscross multiply to get 9 squared of 3 is equal to v squared of 3. Divide by the square root of 3, divide by the square root of 3. And then give v is equal to 9. Hopefully from there you can recognize that u is just twice. All right, thanks guys. I hope this lesson went okay for you. Remember, you don't have to understand both methods. I'm showing you two methods because each of them have their powerful moments and their moments of struggle. And you can choose to use one or the other in any problem, or you could always use the table, or you could always use the ratios. Whatever works. All right, take care. Bye-bye.